Okay, so let's take a look at the second lesson here, lesson 2, the cast rule and the trigonometric ratios. So if we look at our coordinate grid here, and I look at the 4 quadrants, the first thing I want to do is I just want to change these to 230 degrees in my 3rd quadrant and 310 degrees in my 4th quadrant. And the reason for that, we'll see in just a minute, but if we just plug into our calculator and literally type in the sine of 50, we are going to get 0.766. And if we type in the cosine of 50, we are going to get 0.643. And if we type in the tan of 50, we will get 1.192 if we round to 3 decimal places for each of those. Now, what the heck is going on there? Well, here's what's going on. Let's take a look at drawing like a triangle here, a terminal arm, okay? And let's just pretend this is approximately 50 degrees, okay? Here's theta, which is 50 degrees. And I know that my opposite and my adjacent, if I were to move along as if this were a point, I would be moving x to the right and y up. So my point would be positive x, positive y. And if I think of this triangle as a right angle triangle, which it is, and if I think of it in terms of labeling with respect to trig, I know that y would be the opposite and x would be the adjacent. Whoops, adjacent. And my hypotenuse would be here. Okay, my hypotenuse would be right here. And so if we look at this triangle, then I know that my opposite divided by my hypotenuse would both be positive, so I get a positive here, okay? And so on with my adjacent and hypotenuse and opposite and adjacent. Now let's look in the second quadrant, and if we were to plug these values again into our calculator, my sine of 130 would be 0.766 again. Cosine of 50 is going to be negative 0.643, and tan of 50 is going to be negative 1.192. Now, what is going on here? So let's have a look at our second quadrant triangle, okay? And if I were again to draw a reference angle of 50 degrees here, that would mean theta is 130, okay? Because 130 plus 50 is 180, right? We know that's 180 degrees, and that's 90 degrees, and this is 270 degrees, and this is 0 or 360 degrees. Okay, so if I'm looking at the 50, let's look at the coordinates for just a minute. If I look at those coordinates in the second quadrant, if I were to move up to point here, a point, this would be negative x and positive y. And so when I look at the sine of 130, which is really the reference angle of 50, I'm looking at sine, which would be the opposite, okay, over the hypotenuse again. And my hypotenuse is always going to be positive, 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 no matter where I am. My opposite side divided by my hypotenuse would be positive, so that's why we get a positive 0.766. But the cosine is the adjacent divided by the hypotenuse, which is a negative divided by a positive, which gives me this little negative here, and tangent opposite over adjacent, which is positive divided by negative, which gives me a negative, okay? And if we look at the sine of 230, even without using our calculator, I know, looking down here, let's just draw our picture first, and maybe you can envision without using your calculator, would the sign be positive or negative? Let's just see if we can figure that out. So of course, by the way, these are all right angles, okay? And this would be our reference angle of 50. So theta, in this case, okay, in the third quadrant here, let's just do this one in green maybe. Theta here would be, if I zoom around there, theta is going to be 180 plus 50. So theta would be 230 degrees, which is what we've got here. Now, let's look at our points, or our coordinates, this would be a negative x still and a negative y. So this is negative x, negative y. So if we look at this with respect to opposite, adjacent, and hypotenuse, and I'm just going to do this maybe in pink. Let's just do, this would be our opposite with respect to this triangle. Our adjacent is still going to be our x-axis, negative, and our hypotenuse, which is always positive, would be that terminal arm. So if I'm looking at the opposite over the hypotenuse, I know it's going to be negative. The triangle shape would be the same because our reference angle is still 50. So my sine ratio here is going to be negative 0.766 because our opposite side is negative. Our cosine, our adjacent over our hypotenuse, would be a negative 0.643 because it's negative over positive, adjacent over hypotenuse, and then the opposite over adjacent, which are both negative, that ends up being a negative divided by negative, which ends up being a positive, which is a positive 1.192. And then again, in the last quadrant, let's draw that triangle with a reference angle of 50 degrees. Okay, and this is really a bad triangle. So kind of like that. Okay, and here's our 50-degree reference angle. And so theta, in this case, okay, theta would be from our positive x-axis, zooming around here, theta is 360 minus 50, which is 310 degrees. Okay, so there's theta. And this is x, and this is negative y. So our point here is x, negative y. So sine, opposite over hypotenuse, and our hypotenuse, of course, is always positive. So opposite over hypotenuse is negative. So my sine ratio here is going to be a negative 0.766. Our cosine is going to be a positive, right? Adjacent divided by hypotenuse. It may not be obvious, but the hypotenuse is always positive, okay? So our cosine here, it would be a positive 0.643, and our tangent opposite over adjacent, negative divided by positive, will be a negative 1.192. So this demo hopefully sort of describes what is called the cast rule. And if we just draw a little sort of quadrant like this, the cast rule basically says if I look in each quadrant, which ratio is positive. In the first quadrant, all are positive, okay? All are positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive. And in the fourth quadrant, cosine is positive. So if we look here, does that make sense? Yes, in my fourth quadrant, sine is negative, tan is negative, and cosine is positive. In my first quadrant, all of them are positive. In my second quadrant, sine is the only one that's positive. And in my third quadrant, tan is the only one that's positive. So the cast rule, very important. And it says, without the use of a calculator, determine if each ratio is positive or negative. So what I want to determine is which quadrant am I in? So the way to think this through is which quadrant. So what quadrant would 220 degrees be? Well, I know 220 would be in quadrant 3. Okay, there would be 220 degrees in quadrant 3. So if I'm in Q3, I know that tan is the only one that's positive there. So in Q3, sine would be negative. Okay, tan of 140, well, 140 degrees, that means I'm in quadrant 2. If I think about that terminal arm, there would be theta would be 140 degrees. And I know in Q2 that tan is negative because the only one that's positive there is sine. So I know that tan is also going to be negative in Q2. And then cosine of 310, again, which quadrant am I in? Okay, 310, just over here somewhere. Okay, so there's theta is 310 degrees. And so in this quadrant, cosine is, right, cast rule, cosine is positive in that quadrant, okay? So in second quadrant, sine is the only one that's positive, so tan would be negative, and again, cast rule, tan is the only one positive in Q3, so sine would be negative. So that's the cast rule. It tells you whether the ratio is positive or negative in that quadrant. Let's do the next example. It says the point -815 lies on the terminal arm of an angle theta in standard position. Determine the exact trig ratios for sine, cos, and tan of theta. So first thing I want to do is draw a picture. Okay, let's draw a picture here of -8 and 15. So if we do a little sketch there, -8 and 15 would be somewhere around there. And of course, here would be my terminal arm from my origin to my point. And I'm going to draw a perpendicular down to the x-axis. And here's my reference angle, theta ref. Okay, so determine the exact trig ratios for sine, cos, and tan. So the opposite side here would be the 15, okay, because we're moving -8, 8 to the left, and 15 up to get to that point P, okay? Point P, -8, 15. Now, if I want the sine ratio, what I'm going to have to do is I'm going to have to determine my hypotenuse of my triangle. So my hypotenuse would be the square root of 15 squared plus 8 squared. We could put in the negative, but a negative squared is positive, and we're actually just looking at the distance here, the absolute value, the distance from 0, not the direction. So if we figure that out, 225 plus 64, that's the square root of 289, which is 17. Okay, so our hypotenuse is now 17. And if I need my three ratios, I know that sine of theta is going to be the opposite over the hypotenuse. And so this would be the opposite, this would be the hypotenuse, and this would be the adjacent side. So sine of theta would be 15 over 17. Cosine of theta would be adjacent over hypotenuse, which is going to be -8 over 17. And the tan of theta would be 15 over -8, the opposite over the adjacent side. Okay, so those are our three trig ratios of our angle in standard position. So if you would like to pause the video and try to find the ratios for this next picture, give a little picture and find those ratios. Okay, so if we draw the picture and then calculate the hypotenuse, we get 13. And the reason the hypotenuse is always positive is because it's just simply the distance or the length of that terminal arm there. So when we find our ratios, we find the sine is -12 over 13, cosine -5 over 13, and tan -12 over -5, the opposite over the adjacent, which turns out to be +12 over 5. And we know the cast rule, so we know that with that cast rule, the tangent ratio should be the only one that is positive in the third quadrant, which indeed it is. The other two are negative. Just as a little check there, that cast rule helps us out. So if we go into the trig ratios here, where it says primary and secondary. So the primary trig ratios are sine, cosine, and tan. The primary ratios just mean those are the ones that we talk about kind of first. And so opposite over hypotenuse is our name, the name we give to sine is for the opposite over the hypotenuse. And if we were to switch the order, and instead of having opposite over hypotenuse and simply calculate the hypotenuse divided by the opposite, we of course would need a new name. So instead of sine, we call that the cosecant. So this one is sine, and this one would be the cosecant. Okay, and then of course the cosine is the adjacent over hypotenuse, and if we reverse those and we put the hypotenuse over the adjacent, that is the secant ratio. And of course the tangent ratio, if we reverse opposite over adjacent and rewrite it as adjacent divided by opposite, we have the cotangent ratio. And we can call that cosecant, we can call it hypotenuse over opposite, or 1 over sine. So for example, if I wrote it as 1 over the sine over, 1 over sine, which could be the 1 over the opposite over the hypotenuse, I can multiply by the reciprocal, which would be 1 times the hypotenuse. It would help if I could spell the hypotenuse over the opposite, okay? Which gives us the hypotenuse over the opposite. So you can rewrite it as hypotenuse over opposite or 1 over sine, okay? And 1 divided by opposite over hypotenuse is 1 times hypotenuse over opposite, which is simply hypotenuse over opposite. Just thinking of like fractions from junior high, right? Same with cosine, okay? Right? 1 divided by adjacent over hypotenuse is the same as 1 times the hypotenuse over the adjacent, right? We're just multiplying by the reciprocal, which is the hypotenuse over the adjacent. So that's how this is equal to this, okay? And then the same thing with the tangent and the cotangent. Now, sometimes it's hard to remember, and just as a little trick to help to remember which ratio is the reciprocal ratio, sine, opposite over hypotenuse, goes with cosecant. Okay, there's a co in each pair, and then of course cosine here goes with secant. There's already a co in cosine, so there can't be a cosecant because there's only 1 pair in each of the primary and trig ratios. And then tangent, well, tangent and cotangent naturally go together. Okay, so sine goes with cosecant. Okay, sine goes with cosecant there, right? Because there's a co in each pair, and cosine is already a co, so that can't go with cosecant, it has to go with secant. That's kind of a little trick that you can remember. There's a co in each pair. So let's just look at the next example. It says suppose theta is an angle in standard position with terminal arm in quadrant 3, and cosine theta is -3 over 4. So I know that cosine is the adjacent over the hypotenuse. And we usually don't write that negative sign on the denominator. We would either write it on the numerator or in front. But in this case, I know my hypotenuse is always positive, so this negative actually is going to go with my numerator. So we could also think of this as cosine of theta is -3 over 4, which is the same thing. Let's draw a little picture, okay, in quadrant 3. Let's draw a little picture of our triangle in quadrant 3. Okay, and my adjacent, of course, this is adjacent over hypotenuse, so my adjacent is -3 and my hypotenuse is 4. And I know that I can also figure out this opposite side here by using Pythagoras again. So my opposite is going to be the square root of 4 squared minus 3 squared, which is the square root of 16 minus 9, which is the square root of 7. And we would definitely leave that in exact value form. And of course, even though it doesn't say, when we calculate it, we have to add this little negative because we are in quadrant 3. So this coordinate, this point here would be the point -3, -7 on my coordinate grid. Now that we've got all of our triangle sides calculated, I know that this one here, let's just do this in blue, this would be the opposite, and this would be the adjacent, and this would be the hypotenuse. So now that we have all those, we can figure out our exact values. So sine of theta would be -7 over 4, the opposite over the hypotenuse. Cos of theta we already calculated, that was given to us. Tan of theta would be the opposite, -7 over the adjacent, over -3. Ooh, and 2 negatives make a positive, and I also know because of that cast rule that tan is going to be positive, which makes sense because the 2 negatives cancel and make a positive. And let's just do the secondary, okay, the secondary ratios, the cosecant, okay, so cosecant of theta is -4 over root 7, which I'm just transferring those over. Okay, we're taking the reciprocal. Okay, or if I can think of it as the hypotenuse divided by the opposite, right? I can just look at my triangle, or if I have the sign, it's just the reciprocal. Now, this is totally fine for now. I might also want to rationalize, so that would be negative 4 root 7 over 7. And if you forget how we're getting that, we're rationalizing the denominator by multiplying both sides, both numerator and denominator, by root 7 over root 7. Okay, the cosecant, and then let's look at the secant. The secant of theta would be the hypotenuse over the adjacent, which would be 4 over negative 3. And then the cotangent of theta would be 3 over root 7. So I'm just taking that root 7 over 3 and taking the reciprocal of that. And that gives me 3 over root 7. And again, if I wanted to rationalize that, we would multiply by root 7 over root 7. And we really should rationalize. Okay, we get an answer there of 3 root 7 all over 7. Okay, I would recommend that you try the your turn and see if you can come up with those values. So pause the video and give that a try right now. Okay, so for this last example here, the your turn, you're given tan of theta is 1 over 5, and here are your 6 ratios, and I would recommend that you do questions 1 to 6 all. Okay, good luck.